All right, so a log equation is an equation that has a log. So as you can see, I'm going to have the word log in all these equations today. Let me ask you a quick question before I start doing any of these problems. If you don't have a little subscript, do you remember what the little subscript should be? 10. All right, so now me personally, I'm going to write that in here in a second. So really, if it's a common log, that's great, and you can do that on your calculator, but it's got an x attached to it. But if I'm solving a log equation, if they just use a common log, I just go ahead and write the base in there. In a second, that's going to make sense to you why I'm doing that. So just think, if you just see the word log, it has a little subscript of 10. Okay, you want to isolate the logarithm. So all I'm going to do here, I'm going to add 10 to the other side. And I have the log base 10 of x is equal to 2. Now, all we're going to do is we're going to get rid of the log by converting this to an exponential. So here's my log. To get rid of my log, we're just going to swing this base over here. And the base of the log becomes the base of the exponent. So that base 10 is going to push that 2 up in the air. This will be 10 squared, and then I'm done. Other than squaring 10, which would be 100. That's my answer. That's all you have to do. That's it. Okay. Now, the question right next to this, I've got log base 2, and then I have x plus 4 in parentheses. You cannot take and subtract or add or divide things out of the parentheses. So I have the log by itself here, so we're good to go. We're just going to get rid of the log right in the first step. Just change this to an exponential. Remove the word log. You really can drop the parentheses if you want to. That would just, whatever you're taking the log of here, it's x plus 4. Now, the base of the log, the 2, is going to swoosh over to the other side, push that 6 up in the air. And if you want to grab your calculator and check what that is, 2 to the 6th power is 64. And then all you have to do is subtract 4, and then you're done. X is going to be 60 for that problem. Does anybody having a question? Okay. If you got a number down in front here, I have this 4 out in front. Remember, by the power rule, maybe don't write this on your paper, but by the power rule, this would be a 4th power, but actually I would prefer it out in front where it's at, so I don't want you to apply that property. If you have that 4 down in front to get the log by itself, just do one step. I'm just going to divide both sides by 4. All right, now that would give me the log base 8 of this 7 minus 2x. Then I have my log totally isolated. I don't have that exponent out in front or anything. This is equal to negative 3. Now, it's okay for this. We can't take the log of a negative number. It's okay for this to be equal to a negative number. So don't think you're doing anything wrong. I'm just going to swing this to the other side. This is not going to have a nice answer. So I'd have 7 minus 2x equals 8 to the negative 3 power. Now, you don't have to write this, but I'm just going to write on my paper real quick. 8 to the negative 3 is 1 over 8 to the 3rd. So that's going to be like a teeny tiny decimal. It's 1 over 512. I'm just going to do the rest of this question right on my calculator. So I'm going to do 8 to the negative 3rd power. Okay, once I have that, that's 1 over 512. That's why it's such a tiny decimal, but that's okay. What would you do if you knew that that decimal was 8 to the negative 3rd? Like, what would be your next step in solving that equation? Get rid of the 7. Don't divide by anything. Get rid of any addition or subtraction first. So I'm just going to do this like right on the calculator screen. I'm just going to do minus 7. Make sure you use the minus key and not the negative symbol if you're using the graphing calculator. Okay, now that would be equal to negative 2x. So then what would I do? That's not my answer, right? What would I do? I got to do one more thing. Would it be 2 or negative 2? Good. All right, so divide. This has got a little subtraction sign in front of it. So I'm going to divide by negative 2. I'm just doing it right on the calculator screen, so I'm not rounding multiple times. So then my answer, it says go 3 decimal places if needed. So this one we need that for because it's got a nasty decimal. So 3.499, like 3.5. All right, is anybody having a question at the moment? Okay, now I'm going to scooch into equations. These are going to require us to use our log properties. So you don't have a single log. You want to get a single log by itself. It's not too bad, but you got to remember what the properties are. All right, so I've got log base 3 of 9 plus log base 3 of 5x equals 4. I want to try and write this as a single log so then we can get rid of it. So what does addition turn into? Do you guys remember? Multiplication. Everyone wants to like secretly tell me this. Okay, so this would be log base 3. It's like multiplication. I don't want to say it out loud. All right, so I'm going to take 9 times 5x. You can always multiply things together, and if you want to totally just do that and skip writing that out, I just want to show you where it comes from. So addition is going to scrunch together as a single log with multiplication. So this would be the log base 3 of 45x equals 4. Once you're there, you've got a log by itself, so to get rid of the log, you're going to just swing that base over to the other side. So I'm going to have 45x. That 3 is going to push that 4 up into the air to be in an exponent. The base of the log becomes the base of an exponent. So this is 45x. And then you guys might know this, or you grab your calculator. 3 to the 4th power is 81. And then all we got to do to get our answer is just real quick divide by 45. And I don't remember what that is off the top of my head, so I'm going to check. I got 1.8. Is anybody having a question? Okay. The question next to this is kind of two different properties going on in one. If you do have a number out in front of a log, and I just briefly mentioned that in that example, that third example up above there, that number out in front becomes an exponent on whatever follows it. That's the power rule. So if you see like 4 times log base 2 of x, this is really log base 2 of x to the 4th. And then that second term is really log base 2 of 3 squared. I'm just going to write that out. All right, and you don't have to write all these steps, but 3 squared is going to be 9. All right, now, if I have subtraction, what do you do with subtraction? Division. Again, we're going to secretly tell me it's division. Okay, so this guy's going to be log base 2. Now, it really doesn't matter in the question I just did, but in this one it does. So whichever log is first, that has to go on the top of the fraction. So this would be x to the 4th, and whatever comes second, that goes on the bottom. Now, this is not change of base. This is not what we did yesterday. This is not 2 separate logs. This is one log out in front of this, and then the division is going to follow. So it's not like log base 2 of x to the 4th and then a separate log base 2 of 9. It's one log base 2 out in front. Okay, and I'm just bringing down the 7. Now, we're just going to get rid of the log. Swing your 2 over to the other side. You get x to the 4th over 9 is 2 to the 7th power. And I'm pretty sure that is 128. Okay, what should I do from there? I got x to the 4th equals 128. What do you want to do from there? Yes, get rid of the 9 on both sides, and that's probably a big number I don't know. So I'm going to take 128 times 9. And I'm going to get x to the 4th equals 1152. How do I get rid of the 4th power? 4th root. Okay. Now, if you guys, you can do, if I'm being truthful with you, remember a 4th root is the same thing as a 1/4 power. If I'm doing this on my calculator, I'm just trying to do as few buttons as possible. I would just use the little caret button and do that to the 0.25 power. 1/4 is the same thing as a 4th root. So if you do the 1/4 power, you can just do that real quick. If you want to actually use a 4th root to get to that button, you hit your math button. So it's the 4th button down here on the left, and you have to come down to number 5. Okay, now I should have said this real quickly. If you have an 83, you have to type the root first. You'd have to type a 4 and then go get this button. If you have this kind of calculator, it'll let you type the 4 right into the root, and then you can do that 1152. But like I said, I usually just use the exponent whatever the fraction version of that exponent, so the 1/4 power is what I did on my calculator. But this would be 5.826 to 3 decimal places. All right, and then let's do one more, and then we'll do a little bit harder ones on the back. Okay, so for this last one, nothing crazy. This is just subtraction between these two guys, so I'm going to divide. So log base 8, whatever comes first goes on top, that's 6. Whatever comes second, that goes on the bottom, that's x. This is equal to -2. Now, if you want, you don't have to, but if you want to, you can kind of reduce that fraction just a little bit, because 6 is divisible by 3, right? Everything's being multiplied. I don't see any adding or subtracting in that fraction. So I can simplify that fraction. It would just be a plain, just 2 over x. I'm just dividing 6 by 3 is all I'm doing there. But the x would still be in the bottom. This would be -2. I'm going to swing this guy over, get rid of the lobe. So it's 2 over x. 8 to the -2. Now, just to make it a little tiny bit easier for you, 8 to the -2, right? It's 1 over 8 squared, yeah, so it's 1 over 64. The only reason I'm writing it like that, to make it a little bit faster for you, we could just solve this guy like a little proportion, just like cross multiply. So you would just get x times 1, and then 2 times 64 is 128. So it depends on the question. It might turn maybe into like a little proportion, like this one we had a fraction, this one we just divided. It just depends on the question. Okay, now what do you do with 2 logs in the same problem? And maybe 3 logs in the same problem. Each one of these is a tiny bit different. So, do you guys see how on either side I just have a single log and it's base 2, just on either side? How do I solve this problem? Just if you had to guess. What do you think? We would not, we could, but we don't have to do a box on this one. What do you think? They just cancel out, exactly. So this is log base 2 of something equals log base 2 of something different. Literally, I'm not dividing or anything like that, but if they're both log base 2, that forces what's in the parentheses to be equal to each other. So you would literally just do 9x plus 7, 5x plus 31, and then solve that equation. Completely up to you. If it's me, I try to keep my variable positive, so I would subtract the 5x, and I'm just going to do this in the same step. I'm going to move the 7 at the same time. So I'm going to get 4x equals, what's 31 minus 7? 20. Oh, nice number. Good. All right, so divide by 4, and x is going to be 6. Done. Okay, now the rest of these, I'm not going to lie to you, they're not quite as easy as that. So I've got an extra here. I've got on the same side, I've got log base 6 of x plus 4, log base 6 of x, or sorry, x minus 4, then x plus 4. If it was similar to the question above, we could put one on one side and one on the other and just set them equal, that would be great. But this 2 over here is going to throw a wrench into that. So I can't just set them equal to each other. Now, what I'm going to do, I'm going to use my log properties here. If you guys remember, if you are adding between 2 logs of the same base, I don't know why I just wrote a 2. This is a 6. You're just going to multiply these guys together. So the x minus 4 and the x plus 4 is going to get multiplied together. Okay, before I do that, let me just get rid of the log so I don't have so much going on in the problem. I'm just going to get rid of the log. I'm going to do x minus 4 times x plus 4. This would be 6 squared. Get rid of the log. Now, on the left side, FOIL or box, whatever your favorite is. So I'm going to get x squared. This is actually a difference of squares. So if you multiply this out, the middle term is going to get canceled out because you're going to get a plus 4x, but then you turn around and get a minus 4x. So the left side of that equation is just going to be x squared minus 16. And then on the other side, I had 36. You're just going to add 16. So that's going to give me 52. And then I'm going to take square root. Or I could do, what I usually do is the 1/2 power, but whatever's easier for you. And x is going to be 7.211, I'm not on the screen, to 3 decimal places. Okay, does anybody have a question at the moment? All right, this one is a teeny tiny bit weird. I actually have 3 logs. You could put them all on one side of the equation if you want to. I would just leave this like it is. I'm going to use the log properties on this left side. Just put these two together. They're both just a plain log, so they're base 10. If you want to write that in, you can. I usually do to help myself, but you don't have to. And if I put those guys together, since they're being subtracted, what I would do with those two expressions is divide them. So I'd have x plus 1 over 2x minus 3. Now, you can't simplify anything there. Don't go, oh, there's an x on the top and bottom, I'm going to cross that out. No, not allowed if there's adding or subtracting. Just leave it alone. Okay, now the other side, log base 10, it's not written in there, of 8. Okay, now, this is actually super similar to the very first question we did on this side of the notes. I have a log base 10 on both sides, nothing else, just log of something on one side, log of same base on the other side. So I can just, I'm not dividing by this, but we can just drop the logs out. Just do x plus 1 over 2x minus 3 has to be equal to 8. What I'm just going to do real quick is write it as 8 over 1. That way, we'll just do like a tiny proportion here to get the, because I've got variables in both parts of that fraction on that left side. So this would become 8 times, so we get 16x, 8 times 2x, 8 times negative 3 is negative 24. The other side, we're just going to multiply by 1, so x times 1 is x, 1 times 1 is 1, and then that's the equation I'm going to solve. So I'm going to subtract x, and I'm just going to do this right in the same step. I'm going to add 24 to the other side. You're going to get 15x equals 25. And then I'm just going to divide by 15. I don't think that's a nice number. Let me do. It's 1.6 repeating. So it's 1 2/3. Or if you want to reduce the fraction, I would take that too. That would be 5 over 3 as a fraction if you like that better. Okay, now the last two, a little tricky. So I can't just get like a log base 3, 1 on each side because I've got this extra number here. So this is going to be like the question directly above it where we're going to have to do like a little FOIL. So if you have adding between, we're going to scrunch these together. We do x minus 6 times x. All right, on that left side, if I actually multiply that, it's just a little distributive property. It's x squared minus 6x. And to get rid of our lovely log here, I'm going to convert this to an exponential, just swing that to the other side. So we'd get x squared minus 6x, 3 to the 3rd power, which is just 27. And unfortunately, we're going to get a quadratic here. But if you get a quadratic, I promise it will be factorable. So I'm going to move the 27 just to set it equal to 0. And you guys are going to try to tell me two numbers. If I multiply them, I'd get negative 27. The same two numbers I'd add and get negative 6. Perfect. Okay, so one of these is an x minus 9. One of them is x plus 3. Now, here's my two answers. 9, negative 3. And I just want to say one thing to you when you check. There is a potential that you could get an extra answer here. Remember, you can't take the log of a negative number, right? I can't take the log of a negative number. So I'm going to go way back up here. Like if I plug in 9, 9 minus 6 is 3, we're golden. Log of just 9, we're golden. However, if any one of these cause you to take a log of a negative number, it might not work. So if I plugged in negative 3, that's a problem there. That's also a problem there because I'd be taking a log of a negative number. So just be careful with that. If you get a couple answers, check and make sure you're not taking the log of a negative number in the original problem. So just 9 would be the answer. All right, and I'm gonna use one property on this last one real quick. If you guys have a number out in front, that becomes an exponent. All right, so this is really log base 5, x minus 2 squared equals log base 5, 49. All right, so now I just have a log base 5 and a log base 5, each individually by itself. So I can just drop those, and we can do x minus 2 squared equals 49. Okay, do we want to FOIL? No, we don't want to FOIL. Okay, right? I don't want to FOIL. All right, get rid of the squared. I can do that right there. If you have that in that like parentheses squared, dispose of that. We'll just get rid of the squared by taking a square root. Just don't forget, when you introduce the square root, you have to put the plus or minus symbol, because the square root of 49, when I introduce that, could be 7 or negative 7. Now, to solve this, I'm going to add 2 over here. So I would have 2 plus or minus 7. If you can actually add the two numbers, which you can there, do that. So 2 plus 7 would be 9. 2 minus 7 would be negative 5. Okay, would either one of those cause me to take the log of a negative number in the original problem? I would just check just real quick. If I come back up here, if I plug in 9, 9 minus 2, 7, not a problem. However, negative 5 minus 2, that is an issue, because that would cause me to take the log of a negative number. Is anybody having a question? Yes. Yeah, the very first one? Okay, here, I'm just gonna, let me pull this up here.